Hey, all you arcade cabinet builders out there. I just wanted to post a quick video about how I go about designing and building an arcade cabinet. Here you can see four of the arcade cabinets I've built out of the 9 or so that I built over the last 6 months. I've got a stand-up 80s style running with Pac-Man, Donkey Kong, etc. on a 61 JAMMA board. I've got a Raspberry Pi unit here, a 4-player monstrous cabinet, trackball, spinner, everything. Raspberry Pi running about 3,000 classic arcade games. Here I've got a stand-up, more of a 90s style cabinet running a Pandora's Box DX. I think it's got a little over 3,000 games on it. And then this is the most recent one I built, a sit-down racer. It's got an adjustable seat on slides. It's running a PlayStation 3 operating system. Currently running Gran Turismo. It's got a force feedback steering wheel. It also has a Raspberry Pi operating system. So it's got an HDMI switcher internally. The Raspberry Pi is running about 12,000 games. About 450 of them are racing games. So I start off on my computer workstation. You can see over there I designed the side panels in Fusion 360, and then I cut those side panels on my Maslow CNC. This is a plunge router unit capable of cutting a 4-foot by 8-foot sheet. Very low cost alternative to a full-size horizontally mounted CNC machine. This unit runs about $400 plus maybe about another $100 or $150 worth of hardware. So that's controlled by my Windows PC. I use Fusion 360 to design the side panels, and then can export them to the software that runs the CNC machine directly from Fusion. And I will show you how I cut those panels. So here's the latest side panel I've cut. This is going to be for a stand-up Robotron style cabinet that I'm currently working on. So when I cut with the CNC, I do design the whole entire side panel in Fusion. But when I export it to CNC, I usually only export from about here and then this curve around up to the marquee area. So what I'll do is I'll have the CNC cut a channel along there and then stop. And then what I do is I take the full 4x8 panel, I bring it to my table saw here, and I will cut this line, this line, this line, and then usually this is the bottom of the plywood to begin with, but if I need to cut it to height, I'll cut here as well. The Maslow CNC is very dimensionally accurate in the middle of the cut, but as I get towards the edges of the plywood panel, it starts to skew the lines. They're not quite straight the closer you get to the edge of the panel. So I find it easier and more accurate just to cut these with the table saw instead. It also keeps me from having to put tabs and things in here to keep the plywood from collapsing as the router cuts it on the CNC. Since it's only cutting a pocket along there, there's no worries about having to stabilize that giant sheet of plywood. So that's how I do that. In CAD, I do design and plan out what these dimensions are. In this case, I'm putting vinyl graphics on, so it was very important that this dimension be perfect, that the monitor dimension be perfect. I plan out for the size of speaker I want to install, in this case a 4.5-inch speaker set. The graphics for the marquee are a very distinctive, critical dimension, so I plan for that as well. In this case, I'm going to have graphics along the front of the control panel. Again, very critical I get that right. And then I plan to make sure that I've got enough space to access the joystick and the buttons should I ever need to mess with the wiring or replace a button, etc. I don't like to design ones with hinges and stuff. I just would rather close them off permanently and then access from the back side. So I planned that all out, given those key critical dimensions. I personally like to have a control panel that's 41 inches off the floor. So that's this dimension right here. I personally like a monitor that is a little forward facing instead of slanted down like this, like an old classic one. I like them to be slanted a little higher up. I don't like a flat control panel. I like about a 5-degree angle on my control panel. I think it's a little more comfortable. So I plan that in there as well. And then I generally do a 3/4 inch offset from those critical dimensions out to the edge of my cabinet. So that's the line here to here, 3/4 inch spacing. So what I'll do is once the side panel is cut fully, I will take just a piece of 3/4 inch thick scrap and I'll start laying out these offset lines. There's a little bit of wiggle room there. Like I say, the critical dimensions I will keep. But if I wanted to inset these more than 3/4, I would plan for that in the CAD software. So here you can see I've planned for the 3/4 inch offset plus the thickness of the control panel front here. So I've laid multiple lines. From there, I will measure these. So I will take my workshop is a mess, so bear with me. I don't know where I put my angle gauge. Oh well, you guys know what an angle gauge looks like. So I will take an angle gauge, I will measure, I'll make my first cut on the plywood pieces, and then let me grab a piece. Here, we'll use the control panel as an example. So what I will do, let me back up a step. So the first thing I want to do is if I have any edges that are going to be exposed end grain, like right here, I wouldn't want the edge of the plywood. I don't like to miter it or anything there. I usually use butt joints. So what I'll do is I will glue a piece of hardwood edging. So it might be a little hard to see here, but I glued this piece onto the plywood to cover up the end grain. That would be right here. And then I will measure this angle. In this case, it was this angle right here. I will set my table saw to that angle and I'll cut the hardboard edge. And then I will measure back to this corner right here. I will set the table saw to this angle now and I will cut it to that dimension. So I am basically cutting my pieces to the dimensions of my physical side panel. I've planned them out in CAD, but I don't use CAD dimensions. I use physical dimensions off of the side panel. So hopefully that makes some sense. I do undersize things just a tad bit because I can cut this vinyl down. I obviously can't make the vinyl bigger. So I make sure that this dimension that's going to have vinyl covering it from here to the plexiglass of the monitor bezel is just a tad bit smaller than my graphics dimension. From there, I will take and I will drill pocket holes using a pocket hole jig because in the final assembly, this will go as such and will be attached to the side panel with pocket screws. I don't use any type of adhesive. I put plenty of pocket holes so that I get a nice attachment, and I have not had any issue with my cabinets being loose or wanting to come apart. I generally will paint the inside surfaces of the cabinet before I assemble it, precluding me from using any adhesive, as the adhesive would not stick to the paint surface. Haven't had any issues. I drive those pocket screws as tight as can be, and there is no gapping, there is no wiggling, there is a secure connection that will last many, many years to come. In this case, I still have some work to do, so I need to take this control panel and I need to make a dado to accept the plexiglass for the monitor bezel. Same thing here at the speaker grill cutout. Let's see, let me show you that. So here's my speaker panel. I've done the same thing here. I've attached the, let's see, this edge. It's hard to tell. I've attached the hardwood edging to it. I've used my router to cut out the diameters for the speakers. This will go, let me get it in the right orientation here. So this will go right there. It'll have a dado in the bottom of it for the monitor bezel, and it will have a dado on the top here for the plexiglass that I'm attaching the graphics to. Top piece will have a dado for the top of the plexiglass for the marquee. Yeah, any other special cuts I've done? So this is the back top. This will go right here to kind of close that out. Also house my amplifier and things that are up here by the speakers. This is my bottom back closeout. So this will go right here. I've cut this for a power outlet with a switch. So I've made a template on my CNC machine, and then I use a pattern bit to cut out the size for that outlet. So that's a general overview. I will post another video once I get a little bit of the assembly going to show you how that goes. But I wanted to share just how my process works. And if you have any questions, feel free to comment and I'll do my best to answer. Thanks.